So look at this set S. So set S is a plus b root 2, where a comma b belongs to integer. So if a comma b is an integer, so can I say that this set S will have, wait a moment, I'll show you something, such that a comma b belongs to z. Now look at this. Suppose that b is 0. So if b is 0, the whole component will become 0. And if a is an integer, so can I say that set S contains all the integers? Yes. है ना? Now suppose that a is 0 this time. So if a is 0, so can I say that we will have all the integral multiples of root 2? And also when a and b are non-zero numbers, we will have a rational number multiplied with, added with irrational number, or subtracted with irrational number. So can I say that set S contains infinite elements? Okay. Now focus on T1. So T1 is what? This 1 minus root 2. So root 2 is what? 1.414, correct? Now subtract 1 from it. So if you'll subtract 1 from it, you will be left with 0.414, correct? So if you will increase the power now, if you will increase the power of a number which is smaller than 1, it will approach 0. That you know, like suppose you have 1 by 2. 1 by 2 is smaller than 1. So if you will observe this 1 by 2, it is 0.5. Now just increase the power, make it the power to be 2. So it will become 1 by 4. 1 by 4 is what? 0.25. Now again raise the power by 2. So you know that it will keep on approaching 0, 0, 0, correct? So can I say that set T2 is also containing T1 is containing infinite elements, and these infinite elements will approach 0. Okay? And you know that this combination can be taken from here. Like suppose n is 1. So we will get T1 as what? Minus 1 plus root 2, and we can create that thing over here by taking a as minus 1 and b as plus 1. Correct? Now suppose that n is 2. So if n is 2, so I can write a square plus b square minus 2ab. So again I will take a as 3 and I will take b as minus 2, and again I can recreate. Correct? So can I say that T2, T1, T1 is a subset of set S, and both are containing infinite elements, and T1 is approaching 0. Now focus on the next set, T2. So who is T2? Look at this. You know that root 2 is 1.414. So if you will add 1 to it, it will become 2.414. So if you have a number which is greater than 1, suppose it is 2, and you will raise the power na, it will get closer to infinity. Correct? So it will approach infinity. And look at this. Suppose that power is 1. So 1 plus root 2 power 1. So can I say that because n is a natural number? Okay, so if power is 1, you will have 1 plus root 2, and you can create 1 plus root 2 over here by taking a as 1 and b as 1. Suppose n is 2, so 1 plus root 2 power 2 will become what? 1 plus 2 plus 2 root 2. So a will, can I take a as 3 and b as plus of 2? Then we will again have that element in set S. So can I say that set T2 is a subset of set S which is approaching infinity? Set T2 is a subset of set S which is approaching infinity, and also it will have infinite elements. Correct, wrong? I hope till this part you guys are comfortable. Okay, now let's talk about the options. So wait for option A, we will deal it later. Now look at this T1. So who was T1? T1 was subset of set S, and it was approaching 0. It was approaching 0. Now look at this set. This set is also approaching 0. So we will have something in common, correct or wrong? This is intersection sign, na? So we will have something in common, but they are saying that intersection is phi, and phi denotes an empty set. So do you think we will have nothing in common? We will have something in common. So this option is wrong. Okay. Now look at Z. So who is Z? Z is an integer. So you know that Z is also a subset of set S. I will keep B as 0 and I will take all integral values for A. So we will have Z as the subset of set S. T1, already you have proved that T1 is a subset of set S. T2 is also a subset of set S. So if you will take union, you know that everything is derived from set S only. So the papa set for this set is set S. So this option is correct. Okay. Now look at the option D, T2. So you know that T2 is a subset of set S. Okay. And you know that T2 is approaching infinity. Look at the set this. This is also infinity, no? It contains infinity, bigger number. So if we will take intersection, we will have something in common. Now look at this. They are saying that it is not empty. It is not empty means what? We will have something. And this is what we have concluded. This means option D is also correct. Okay. Now let's come back to option number A. A comma B belongs to Z. Cos something plus iota something is equal to Z. So Z is an integer. You know that. And Z is an integer which is a real number. So look at this. Cos theta plus iota theta is producing a real number. So it will produce real number when? Like suppose that Z is A plus iota B. You know that if we will talk about purely real number, purely real, you know that the imaginary part will be 0. Purely imaginary, the real part will be 0. Correct? So look at this again. So they are saying that it will become Z means integer, means real number. So this is real number. The real number means what? Imaginary part should be 0. So can I say that sine of pi a plus b root 2 is equal to 0? Correct? Imaginary part has to be 0 na, to produce a real number, purely real. Now when sine produces 0, so sine produces 0 at 0 degree. Now do you remember that we have handled in trigonometry, we have handled this situation where we used to write general solution. So sine theta is equal to sine alpha, then theta will be equal to a plus b root 2 is equal to n pi plus minus 1 power n alpha. So who is this alpha? Alpha is 0. So if I will write 0, this component will become 0 and n is an integer. Okay, now you know that this thing will become 0. Now can I divide both sides by pi? So we have a plus b root 2 is equal to n. So it is an integer. This is what? An integer. So and you know that this is also integer, this is also integer, but the integer is multiplied with an irrational number. So we have to remove irrational number, है ना? If we will remove irrational part, then only we will have only rational part, means rational part na, which is n. This means this has to be 0. So b root 2 has to be 0. You know that root 2 is something 1.414. So the all responsibility is on b to become 0. Now look at this. For a given a comma b belongs to z, cos of this plus iota sine of this belongs to z if and only if b is 0, which we have concluded. This means option A is also correct. I hope the idea is clear. Okay.